All right, so last one in the group. If you are signed up for the lab section, we're going to use the concept from this question quite a few times. But basically, if you've got torque in one direction, you can balance it with a torque in the opposite direction. And if you know bits and pieces of information, you can use that to see what it would take to necessarily balance and solve for something new. In theory, what we have is whatever torque we've got going clockwise is equal to opposite to whatever torque we have going counterclockwise. And so technically it should be radius times force, but the nice thing is if everything's under the influence of the same gravity, then gravity basically cancels out of the equation, right? So what happens if we think about where these have come from, radius times a mass times gravity is what we looked at in the last two questions. We just kind of did the mass and gravity part first. Um, but because gravity is going to be the same for both people, then as it turns out, it can cancel from our equation. And so we don't technically have to convert here, even though normally it's breaking the rules. The big caveat there, the main difference, is this only works when there's just one pivot point. So if this was some kind of setup, like a big platform that was supported from either end, we would be able to take this shortcut. The fact that it's a seesaw that has one pivot point at the center means that we can almost set this up like a proportion, except that they're directly related instead of indirectly, or sorry, indirectly related, inversely proportional instead of directly proportional. I'll learn English someday, promise. All right, so from here we can plug in our numbers, um, find the distance. So I don't know where this person sits. I'll just put R1, I guess, because they're first. Their mass is 35 kilograms. Then the other person is sitting 1.71 meters away, and their mass is 77 kilograms. So keeping in mind that this person's more than twice as heavy, let's see what effect that's going to have on the other person when we start solving. Nice thing here, kilograms and kilograms cancel. So the way that this lines up is part of why we were able to cancel gravity in the first place. Then, well, here we've got 35 times that radius we don't know, so we're just kind of stuck with that. But on the other side, 1.71 times 77 is something we can work out in the calculator. So 131.67. And then to finish solving down for R, divide by the 35 that's in the way. And we get this radius then is about 3.76. So notice that in order to make the same torque, the smaller kid, the lighter person, had to sit considerably further away. This person was twice as heavy at 77 kilograms, but this person was twice as far at almost 4 meters.